Hey pre-calc kids, today's topic is going to be super easy because it only adds a small piece to what we did the previous day. We are only adding y-intercepts. A y-intercept is where it crosses the y-axis, and you do it by setting x equal to 0 and solve for y. Now I want to be clear here, zeros and x-intercepts are the same thing. So in today's worksheet it says what are the zeros, or it says what are the x-intercepts. I believe it depends on what version you have. So we are going to graph. We are going to find the zeros, state the multiplicity, find the y-intercept, and use our end behavior to sketch the graph. Now if you notice, this one is not factored, so I'm going to factor. There is no greatest common factor, and there are 4 terms. So when there are 4 terms, remember you cut it in half and take the greatest common factor out of both sides. I have 3 x's here, I have 2 here. I have 3 and I have 2. So I can take 2 x's out of each of those. When I do that, I have 1 x left here and I have no x's there, which means I need to leave a 1. Take this piece, the x minus 1, put it on the other side. Those have to be the same. And then ask yourself, what do I multiply x by to get negative 9? I multiply it by negative 9. Now the 2 things you have underlined, those x minus 1 pieces, you write that once. And your other set of factors comes from this. So that is x squared minus 9. Now this x squared minus 9 should raise a red flag because it's a difference of perfect squares. So that will be x plus 3, x minus 3, and then I'm going to carry down x minus 1. So now it is in factored form. Your zeros, you set each of these equal to 0 and solve. So x minus 1 equals 0, x plus 3 equals 0, and x minus 3 equals 0. So x will equal 1, x will equal negative 3, and x will equal positive 3. None of these repeat, so they are all singles. There's only one of each of them. So I've taken care of the zeros and the multiplicity. Now let's find our y-intercept. Remember, to do that you plug in 0 for x. So 0 to the third minus 0 squared minus 9 times 0 plus 9. These are all gone, and my y-intercept is 9. So let's plot all of these points. X equals 1. X equals negative 3. X equals positive 3. And y equals 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we need to figure out our end behavior. Now remember, end behavior is determined by your leading coefficient and the degree. So end behavior is determined by your leading coefficient, it's positive, and the degree on this one is 3. So a positive and a degree that's odd would mean it's going to go down, up. So with that, you go to the furthest left, and it's going to go down, and then you go to the furthest right, and it's going to go up. We said all of these are single, which means you pass through each point. So I'm going to go up, I'm going to catch my y-intercept, I'm going to come down, I'm going to pass through, and then I'm going to come up and I'm going to pass through. This one is factored for you. So we're going to find our zeros first. X equals 0, x minus 5 equals 0, and x plus 2 equals 0. So x equals 0 is our first, x equals 5 is another, and x equals negative 2 is a third. They only appear one time each, so they are all singles. Let's go ahead and find our y-intercept. 0, 0 minus 5, and 0 plus 2. So I have 0, and this is negative 5, and this is positive 2. Well, remember, anything times 0 gives you 0. So y equals 0. And behavior is determined by our leading coefficient and our degree. So our leading coefficient out in front here is positive. The degree is how many factors you have. I have 1, I have 2, I have 3. So it's 3. So we are going to have the exact same end behavior as we did with the first one because our degree is odd and our leading coefficient is positive. Look at that chart, you guys. You can use that chart, obviously. X equals 0. X equals 5. 1, 2, 3, 4, 5. And x equals negative 2. So with this, again, on the far left, you go down. On the far right point, you go up. They're all singles. Your y-intercept is also one of your roots, so you don't have to even consider it. Because they're all singles, you pass through, you turn around, you pass through, and then you pass through. All right, one last one. This one is not in factored form, so I'm going to take out my greatest common factor if I have one. I don't have a greatest common factor as a number, but I do as a variable. I have 2 x's in each. When I take out 2 here, I'm left with 1. I take those out, I'm left with minus 9 equals 0. 2 x's out here means I have x equals 0, I have x equals 0, and I have x minus 9 equals 0. When I solve that, I get x equals positive 9. So that's one root, that's another, and that's a third. But these two repeat, so we call this a double. This one is by itself, we call that a single. So I've done my zeros and my multiplicity. Now let's do my y-intercept. So 0 to the power of 3 minus 9 times 0 squared. Again, lots of zeros, and your y-intercept is also 0, which happens to be what your roots are, so you don't even have to look at it. And behavior. I have a positive leading coefficient, and my degree is 3. So same end behavior as the previous ones. I'm going to put a dot at 0 and 1 at 9. Furthest point is down. Furthest point on the right is up. Now, because 0, which is the point right here I'm at, is a double, that means you go to it, you hit it, and you go back down. So it kind of creates a V. It's like you're bouncing off the edge of a pool table. You hit it, and you go back down. Now 9 is a single, so I have to turn back towards it and pass through. All right, make sure you're asking questions, engaging, give us calls on Google Meets, whatever you need to do. Miss you guys.